Hi, in this video, let us discuss exception handling in Python. What is exception? Exception is a runtime error. So when your program is in execution due to some unexpected situations or unexpected issues, some error may be raised and that is called exception. What will be the effect of exception? If an exception is happening in your function, then one exception object with an error message will be thrown and that will be thrown to the calling function. And when your calling function is prepared enough to receive that exception and process it or handle it, then your program will run continuously without any interruption. So what will be the effect of this exception in your program is normally unexpected halt in your execution of the program. So if you want to avoid stop the execution of your program when an exception is happening, then it should be handled properly with proper mechanisms. Python provides an efficient exception handling mechanism to handle the exceptions. Let us have a small example. Suppose let me declare a variable x in my program, or otherwise let me use the variable in my program without declaring it. So normally in our Python there is no declaration concept because declaration is a way of saying to the compiler that this is the type of your data or value or variable. But in Python it's a dynamically typed language, so it will accept any type of data in any variable. So no need of declaring it. At the same time, if you are trying to use a variable in a computation which is not already initialized, then that will be an error. So here, let us discuss how to handle this kind of exceptions in our programs. A set of statements that will be generating error or expected or suspected to generate error are kept within a block that is called try block, or it's a try is a class that is a name for a set of statements or a block of statements that are suspected to generate an exception. And when an exception is there, then there should be a handler to handle it. And handler is nothing but a code. It's a program that is executed in response to an exception in your program. So when try is a collection of statements that is actually expected to generate errors or exceptions, catch is actually or except is actually the block that is containing a set of statements that are going to handle the exceptions, otherwise called as exception handler. So now we have to discuss try and except. So what is try? Try is a collection of statements that are going to be suspected that creating the exceptions. And what is except? Exception is a set of statements that are executed in response to your exception. So what's the syntax of mentioning this try and except in your programs? Try keyword, then a colon, then a set of statements which are expected to generate exception, and then followed by one or more except blocks which are the exception handlers executed in response to your exception. Now let us have a small sample code to be executed. Let me print a variable x, but this x is not defined. That means its value is not initialized. So when I run this code, what will happen? Let us check it. So when you are trying to use a variable or when you are trying to print a variable that is not initialized, it is giving an error or exception name x not defined. So this is the exception thrown and the execution of the program stops at that point itself. Now what we can do is we can handle this exception by keeping this print statement within a try block. So as we discussed, try block is a collection of statements that are expected to generate this exception. When there is a try block, then there should be a corresponding at least once except block. So except block is a collection of statements which are handling the exceptions. Now general except block is like this: except keyword, then a colon, then a set of statements, one or more statements which are executed in response to this exception. For example, print exception not, sorry, X not defined, right? So once this is done, what will happen when an exception is thrown, then the except block will catch it and handle it. After that, the immediate next statement after the last except block. For example, let me give one print statement here. Execution continues, right? So I am giving one statement here, print exception continues. That is immediately after the except block. So once an exception is happening, then except block will handle it, and whatever there within this except block will be executed. Here we have a print statement, so it will print a statement in the output screen, X not defined. After that, it will continue the execution of the program from the statement next to the except block. Now let us run this code. So if you see the output, you can see an exception thrown because here it is clearly it is intimated that it's unresolved reference X, and that's an exception, and that is caught by this except block, and it is printing or it is executing whatever there inside this except block. Here it is a print statement and it is printing X not defined in the output screen. After that, the execution continues without any interruption from the statement next to this except block. So that means the print statement is executed, and that is printing the message execution continues. So this is the basic try and except blocks mechanism to handle exceptions in Python. Now we can have multiple except blocks for a particular exception, right? For example, let me create one more exception here. So what's happening is I am initializing this X here. Okay, I am initializing this X here, so X is equal to 10, right? X is equal to 10, or then I can divide this X by 0, right? Otherwise we can do one thing, so we can omit this declaration or definition of X. I am saying this X by 0. So now this may generate two types of exceptions. One is the X is not defined, so that is name error or it's a name exception. And second exception is if a number is divided by 0, so it's not defined in mathematics, so it's defining or it's creating an exception, 0 division error. So here two exceptions are possible in this statement. Now I can have two different exception handlers or except blocks in my program corresponding to this try block. So what can I do is I can have a separate two exception handlers in the name of the exceptions I expect from that particular statement, right? So one exception I expect is actually name error. So name error. So this is one error that I expect from this statement. And for that, I am giving a response or exception handler code that is X not defined. Then after that, another exception possible from this statement is 0 division error. So except then 0 division error, 0 division error, 0 division error, and that is the next type of exception possible. So in that case, what I do is let me give another print statement in it, right? So print division by 0 is not defined. Division by 0 is not defined. Now you see here there are two exceptions possible from this statement. For the two exceptions, I provide two separate exception handlers. So it's not a professional way of programming or professional way of handling the exceptions by having single except block or single exception handler for all the exceptions possible from a code. So here we provided two different exception handlers for the two different exceptions possible from this statement X divided by 0. Now after that, what is the next statement immediately after that exception is to be continue. So that is print of execution continues. Now let us run the code again. If you check the code here, the first exception part actually happened was X is not defined. Even though there is another exception that is division by 0 is available or it is possible in that statement, but still the first exception thrown is actually name exception or name error, and that is caught by this first exception handler, that is corresponding to this name error, and the statement within that exception handler is executed, and that is printing x not defined in the output screen. After that, the remaining exception handlers are skipped because any one exception handler can handle that particular exception, and the program can continue its execution. So the program's execution continues here. So this is how we can have multiple exception handlers corresponding to single exception or one or more exceptions. And next one is, we are having multiple exception handlers separately for every exception. It is possible to club those two different exception handlers or multiple exception handlers together into a single exception handler by having an exception handler that can handle more than one exception at a time. Let me have a small example of it. Except, then within set of parentheses, I want to mention the different exceptions that can handle or that can be handled by this exception handler. So first is name error, that is the first exception, and second one is zero division error. So this is the second exception that is going to be handled by this exception handler. Now here let me give a small print statement, that is x is not defined or division by 0 is not defined. So here I am giving a print statement that is printing the statement either x is not defined or division by 0 is not defined. So because there are two different exceptions that can be handled by this exception handler, and if any exception that is matching, if this name error or zero division error, then the code within this exception handler will be executed, and so that it is giving the message x is not defined or division by 0 is not defined. After that, as usual, the statement next to the last exception handler is continuing, or it is continuing its execution. Right now, let us run the code again. Yes, see, now an error was there. What is that? Name error. So since name error and zero division error both are handled by the same exception handler, now here the code corresponding to this, or which is there in this exception handler, is executed, and it is printing the statement x is not defined or division by 0 is not defined in the output screen. So after that, the execution continues from the statement next to the exception handler, that is the print statement that is here, and that is printing execution continues. So this is how we can make an exception handler that can handle multiple exceptions at a time. And now next is else in exception handling. So we can provide an else block in our exception handlers. Normally, when this else block will be executed is, suppose you are expecting an exception in a particular code, but during runtime an exception was not thrown by that code or that function, then else block, whatever there in the else block, will be executed. Right? So else is a collection of statements, and that is going to be executed when there is no exception happens in your program. Even though you are expecting exception, but it is not happening. In that case, the set of statements that are in the else block will be executed. Let me give else block here. And within else block I can provide a set of statements. Now execution continues is the statement that is provided in this else block. Right? Let me make this code not having any exception. For example, x is equal to 10, and x normal division by 10. So there is no error in this code. X is properly defined and it is divided by 10. It's a valid division operation. Now exception is not possible. In that case, surely this print statement in else block will be executed. So else is a block of statements will be executed when there is no exception happens in your program. So now let us run the code. So if you see the code, there is no exception. Instead, a valid output is actually given by this print statement, that is 1.0. So 10 by 10, that is 1.0. After that, since there is no exception, then the set of statements belong to this else block are executed. That means here the print statement available in the else block is executed so that execution continues is printed in the screen. So this is how we can provide an else in our code or in exception handling. And next is finally. Finally is a block of statements to be executed regardless of the presence or the happening of the exception. So even if the exception is not happening, then the finally a set of statements will be executed, or finally statements will be executed. So finally is a collection of statements to be executed, either or okay, even if the exception is not happening or not arising in the particular program. So it's a compulsory set of statements to be executed. It's a compulsory statements to be executed. Now let us have a small sample on that. So here what I do is I am giving finally, right? So here I am making the exception. I am making the exception because X is not defined. So exception is possible. So when exception is possible, surely the exception handler will handle it. Okay, exception handler will handle it, and after that, the statement that is there in the finally will be executed. Right now, let me run the code. Now, if you check the output, exception was thrown and X is not defined or division by 0 is not defined. So that message is printed. After that, the set of statements in the finally, especially this print statement in the finally is executed and is printing the statement execution continues in the output screen. Now let me make this code not generating any exception. So X equal to 10 and X is equal to X by 10. So there is no exception in this code. But if I execute this, again the set of statements available in the finally will be executing. So since there is no exception and it is giving the proper output 1.0 as a result of the print statement, after that it is executing whatever there in the finally block, and that is execution continues. So this is how the finally block is working in exception handling mechanism in Python. Now the last one is raising an exception explicitly or raising a manual exception. So generally, if a particular issue is happening, then exception will be generated and thrown automatically. But it's possible for a programmer to generate an exception by himself. Okay. So any exception can be manually thrown, or we can generate an exception whenever required, and we can handle it too. Right? So let us check how this manual throwing of exception is happening. For example, let me have this X is equal to 10. Okay, X is equal to 10. Now what I do is X is equal to 10 is actually properly declared or defined. So now let me print X. Let me print X. Now X is printed, right? X is printed. And now when I'm giving a condition, right? I'm giving a condition. If X modulus division by 2 equal to 0. So what does it mean? X is actually an even number. So when X is an even number, I am throwing an exception explicitly. So what keyword I want to use to throw an exception is raise keyword. So raise is the keyword that is used to throw an exception explicitly, and I want to mention an exception class. Okay, when I'm throwing an exception explicitly. So here, raise is actually the keyword that is used to raise an exception, space, then exception, and this is the exception, base exception of all the exceptions. Then I want to mention a message to be paused or displayed when an exception is happening, right? So for example, even number not allowed. So this is what the exception I am going to raise from this statement. Now, if this is the exception, then what I want to do, I want to handle it. Okay, I want to handle it. So as usual, what I want to do is I want to have an except block. So except. So this except block will handle this particular exception. Now let me have a print statement in this exception handler. For example, even number exception, and after that this exception handler I am printing another I'm having another print statement that is going to print a statement in the output screen, execution continues. Right? So now what will happen when x is even number? So it's already even number. So then it will raise an exception with a message even number not allowed. Then it will be caught by this exception handler except, and it will print a message even number exception, and it will continue the execution of the program from the statement next to except block that will print execution continues in the output screen. Now let us run the code and check how it is working. So you see x is 10 and you are printing x and no problem. At the same time, when x is divided by 2 and you are getting remainder 0, it's even number, and at that condition 10 by 2 is actually giving remainder 0. Then you are raising an exception manually, and when you are raising the exception manually, then what you give in the exception handler or except block is executed, and that is printing a statement even number exception in the output screen. After that, the program continues its execution from the immediate next statement, and that is printing execution continues in the output screen. So this is how the exceptions can be thrown manually or explicitly and handled. In this video, we have discussed what is exception and what is try except, and what is how to use else block, right? How to use finally block, and how to raise exceptions manually in our programs. I hope that you understood the concept and keep on practicing. Happy programming. Thank you.